Hello students, welcome to the theory class, seed production of vegetable, tubers and spice crops. Today's topic is on seed drying. To start with, let's discuss what is a seed drying. Seed drying means removal or elimination of moisture from the seed at an optimal level. And why we need to do so? Most of the seeds that we used to sow in the field are not from the freshly harvested seeds. We need to store it for a certain period of time before sowing, because in order to wait for the next cropping season. During this storage period, we need to maintain the viability and vigor of the seeds, which can be attained by reduced moisture content of the seed. Not only so, we are going to reduce the amount of microbial activity, fungal and bacterial activity in the seeds if we reduce the amount of moisture content in the seed. So next, here we have the methods of seed drying. There are three different methods: sun drying, natural drying, forced air drying or mechanical drying, use of desiccants or chemical drying. Coming to the first one, sun drying, it is an easiest process in which we are going to spread the seeds over the ground, and or it can be spread over a tarpaulin sheet. It is a traditional way of drying, and we are going to avoid drying during high sunlight intensity, because it may also damage the seed. As sun rays also contains UV rays, it may also damage the seed. That's why we are going to avoid during 12 to 2 p.m. In the afternoon. Some of the advantages of this method is it is an easy, cheap method, and it requires no additional equipment. It does not require any expenditure on electricity and fuel. Some of the disadvantages here can be mentioned as more chances of mechanical admixtures is there. Since we are going to use mechanical devices like hoe to spread the seeds, and seed losses are of great risk because of the infestation by insects and animals here, and it takes long time of drying, like it takes 1 week of time to dry, and even more than that in some seeds. Uneven drying is there. If the spread of seeds over the ground is thick, there will be uneven drying, and there is a great risk of damage by uh, unexpected weather conditions like rainfall or hailstorm. Next one is forced air drying or mechanical method of drying. In this we have three different subheads: natural air forced drying, drying with supplemental heat, and heated air drying. In the first type we have here, it is a process in which a blower is used to infuse air into a chamber where the seed lot is present. And in this process we are going to use a natural air where the blower is going to suck air from the natural air which is from the nearby environment, and we are going to infuse it into the seed lot or a chamber. Okay, and it also, there is a great risk during winter and rainy season, as the air present in the external environment is having high relative humidity. If we blow the air with high moisture content, it will increase the amount of moisture content instead of decreasing the amount of moisture content in the seed. In order to reduce such a problem, we are using another type of drying method, which is drying with supplemental heat. You can see here a white arrow and a black arrow. White arrow indicates normal natural air, black arrow indicates supplemented heated air. So in this process the natural air is heated up to a temperature of 10 to 20 degree Fahrenheit. And right here you can see a traditional type of mechanical drying with supplemental heat, which is used in Tamil Nadu Agriculture University, Coimbatore. Next one is heated air dryer method, in which we are going to use a chamber. We are going to supply the heated air as much as 100 degree Fahrenheit or 40 degrees Celsius, and it is a very quick method of drying. It is used for drying those seeds which are having high moisture content at a short period of time, and there is a certain should be done during this drying method. It is called tempering. We are going to discuss this at a later stage of this slide. And type of dryers used in this mechanical method of drying. Here are metal bin dryer, vegetable seed dryer, and batch dryer. So in metal bin dryer, the seeds are placed in a metal bin and the heated air is blown into the bin through a perforated layer on the bottom of the bin. In this, uniform drying of all the layer is not possible, so we need to stir the seed load inside the metal bin from time to time. It can be of cylindrical shape or it can be on rectangular shape depending on the use and requirement. So next one is vegetable seed dryer. So in vegetable seed dryer, it is similar to, it can be of different forms, but sometimes it is similar to an oven. So in this we are going to use seed racks. Okay, since the seed harvested can be stored in the different racks of the content of the oven, so the seed drying process is quicker compared to the metal bin dryer because it is highly stacked and it is compactly stored in the bin, while in this process it is spaciously kept in a dryer. So the drying process is a little bit quicker compared to other type of dryers. Next one is batch dryer. So in this process the seed is placed in a usually round bin, and ambient or slightly heated air is blown through it by a fan, and maximum thickness of the seed layer in the bin depends on the seed layer depends on the initial moisture content of the seed, the type of seed, the air temperature and relative humidity, and the fan horsepower. To obtain a uniform airflow through the seed, a full perforated floor is required. So for example, for a seed of 0.8 to 1 meter at 20% moisture can be dried up to 14% within 24 hours of time without affecting the germination at 30 to 35 degrees Celsius and 50 to 60% relative humidity air at the rate of 5 to 8 meter cube per minute and per 3 meter cube of seeds. So during this process the same problem is there. Okay, with the metal bin dryer, some of the seeds which are on the top have moisture content higher than the average of the seed load, and some of the seeds which are on the bottom have moisture content lower than the average of the seed load. So a mechanical device which assists in steering the whole seed load is installed, has to be installed in the batch dryer. Okay, and it has to be continuously steering the seed load during the entire process in order to uniformly distribute the heat or uniformly distribute the moisture content over all the seed load. Next one is Wagon-Batch Dryer. A seed transport wagon is transformed into a Wagon-Batch Dryer by equipping it with a batch dryer. So in this process the process is quite similar to the Wagon-Batch Dryer, and this is frequently used for drying fragile seeds such as large seeded seeds like field bean and peanuts. The recommended airflow and for the ambient air wagon dryer of 1.5 meter tall layer of peanut seed is 0.25 meter cube of air per meter square of floor area. And next here we are using the desiccants, some of the desiccants which are formed by chemicals. Use of desiccants. In this method, silica gel or fused calcium chloride is used to absorb the moisture from the seed and its surrounding environment. So the seed granules, these silica granules and calcium chloride granules has to be included into the seed lot in order to reduce the amount of moisture. So the uh, amount of moisture which the silica gel can absorb is 15%, while the amount of moisture which the calcium chloride can absorb is 10% of its weight. Okay, so in case of silica gel there are two types, indicator type and non-indicator type. So if we have to detect the amount of moisture into the seed load, we can use indicator type, okay, which is blue in color, while for those where amount of moisture content is not detection of amount of moisture is not required, we are going to use non-indicator type silica, which is white in color. So it comes with blue color, and when the moisture content is high and when the moisture is absorbed into the blue color silica gel, it will turn into pink color. Okay, this is an indication to the presence of moisture content in the seed load. And if the indicator is yellow color, which is the silica gel is of two type, blue color and orange color. If the indicator is orange color, it will turn into brownish or darker color. While calcium chloride doesn't have any indicators, and it is used in specifically in those seeds where breeding is to be done, and storage of flower seeds is done. Some of the advantages here are it is having less time consumption. A drying process in this method is uniform, and some of the disadvantages here are it cannot be used in large scale as the chemical here are very costly. It cannot be used, a skilled person is required to monitor the operations over drying, because over drying may also occur during the chemical drying. And coming to the next slide, we have here some of the factors which decides the rate of drying process. First one is moisture content of the seed. Initial moisture content of the seed is required because prior to drying we need to decide if the seed is harvested from a freshly freshly matured plant, or if it is from a already dried one, and which needs to be dried at an optimal level. So drying process requires this is one of the important factor which decides the drying process. Next is the existing relative humidity and temperature of the environment. We can see the example of forced air drying of natural air. If we force the air of the external environment with high relative humidity, it will increase the relative humidity or moisture content of the seed instead of decreasing the moisture content. So in this process things should be taken care. We don't infuse air from the high relative humidity environment. Next one is depth of spread of seeds. So in the mechanical dryers, so depth of seed storage should be at optimal level, should be 1 to 1.5 at the max. If more than that, there won't be uniform spreading, because some of the seeds may be over dried on the bottom, and some of the seeds may not even dry on the top layer of the dryer. So uniform drying is necessary, and also at this time we need to provide a mechanical stirrer. And next one is rate of air blow. So rate of air blow should be at the optimal level, and it should not damage the seed. Next one is drying temperature should be, and again drying temperature should not damage the seed viability and vigor of the seeds. Next one is size and capacity of the dryer. The capacity of the dryer should be at an optimal level, and it should dry the seed load, and it should capacitate the amount of harvested seed, and it should dry the seed load at an optimum time period. Next is kind of seeds. We have learned about the type of seeds like orthodox seeds and recalcitrant seeds. In orthodox seeds, we have to reduce the amount up to 10% of moisture content, and in recalcitrant seeds we have to reduce the amount up to only 20%, because lesser than that the viability and vigor of the seed will get lost. So things should be taken care during the drying process for these two different types of seeds. And coming to the tempering process, which is required in heated air drying method. Tempering is nothing but during heated air drying method, the outer layer of the seed gets dried quite quickly compared to the inner layer, which develops a pressure between the inner layer of the seed and the outer layer of the seeds. Due to this pressure, the viability and vigor gets damaged, and in order to save the seeds, we need to keep the seeds without heating for a certain period of time in order to spread the moisture inside the inner layer of the seed into the outer layer of the seeds uniformly. Okay, so this process of allowing the moisture spreading, uniform spreading of moisture from inner layer of the seed to outer layer of the seed is called tempering process, and it is necessary during heated air drying. Okay, and thank you for listening.